Okay, today is Wednesday, February 6th, and we are continuing right along with Eureka Math Module 4, Lesson 8, okay? And today, your learning goal is by the end of the lesson, you should be able to explain how you can use what you know about factors to help you multiply fractions and whole numbers. Okay, so we're going to use what we know about factors to help us when we're multiplying fractions and whole numbers, or adding on to what we learned yesterday. Go ahead and write 2/3 times 6. We know that's the same thing as 2/3 of 6, right? Because this really means of. If I want to find 2/3 of 6, can't I draw my tape diagram? I say the whole thing is 6. I divide it into thirds, and I want to find two groups. Yes? What would I write next to complete that? How many units do I have altogether, everyone? 3 units equals what? Okay. Then 1 unit will equal 6 divided by 3, which is 2. But how many units are we trying to find here? 2 units. So I have to do 2 units will equal 2 times 2, which is? So what's 2/3 times 6? Huh? 4. Yeah. Okay, so we know that this equals 4. Now, if I go back up to the top, 2/3 times 6, is that the same thing as 6 times 2/3? What property tells me that I can move or commute those terms around and it won't change the value? Akil? The commutative property of multiplication. Very good. Do you guys agree that 2/3 times 6 is the same thing as 6 times 2/3? Mm-hmm. Yeah. If I have 6 times 2/3, doesn't that mean I'm making 6 copies of 2/3? Go ahead and write that down. That's the same thing as 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3. Do you agree? Mm-hmm. Yeah. So if I have 2/3 plus, and I add another 2/3, how many thirds do I have? 4/3. If I add another 2/3, how many thirds do I have altogether? 6 thirds. What if I add another 2/3? 8 what? 8 thirds. Okay, what if I add another 2/3? 10 thirds. What if I add another 2/3? I have 12 thirds. Do you guys see how we know that repeated addition is the same thing as multiplication, right? So 6 times 2/3 is the same thing as 2/3 plus 2/3 plus 2/3, which when we add those up, we get 12 thirds because 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2 is 12. Do you guys see how that's the same thing as doing 2 times 6 over 3? So that means 6 times 2/3 is the same thing as 6 times 2 over 3, which is 12 thirds. Did you guys see that? Write in your notes how you know that's true. Explain it to yourself using words. What I wanted you to see by doing this is that when you have a fraction, such as, what was the first fraction we had? 2/3 times 6. That was the same thing as 2 times 6 all over thirds. Did you see that? Mm-hmm. Same thing, when we had 3/5 times 10, it ended up being the same thing as 3 times 10 over 5. Did you guys see that? Mm-hmm. Okay. I wanted you to notice this pattern because that's what we're going to build on today for the rest of the lesson. Okay. By the way, what was 2 times 6 over 3? It's 12 thirds, which was 4. And then this was 3/5, which was 6. Today we're going to use what we know about factors to help us solve multiplication problems easily. What is a factor? Tarun?
A number that can multiply another number.
A factor is any two numbers that are multiplied together. Okay, so 2 times 2 equals 4. What were the factors? 2's. Good. 10 times 2 equals 20. What are the factors?
10 and 2.
10 and 2. Very good. So the example shows 2 different ways to multiply a fraction by a whole number. You'll see first we have 6 times 2/3. We know that's the same thing as 6 times 2 over thirds, which is 12 thirds, which is 4. We did it that way. Yes? Okay. See if you can figure out what's going on in the example here. 6 times 2/3, you can see originally it says 6 times 2 over 3, and then they crossed out the 6 and wrote a 2, and they crossed out the 3 and wrote a 1. What's going on there? So what we can notice in the example is that both 6 and 3 are multiples of 3. So 3 is a common factor. They share a common factor. If I divide 6 by 3, what do I get? If I divide 3 by 3, what do I get? So what did they divide this part by? What they did was they divided it by 3 over 3. They divided a number in the top, in the numerator, by 3, and they divided a number in the denominator by 3. Why is it okay to divide by 3 over 3? Because 3 over 3 is really a version of what? 1. And if I divide by 1, do I change the value? No. So you can always divide by 1, which doesn't change the value of the problem. So 3 over 3 is a version of 1. Could I divide by 5 over 5? Sure, that's a version of 1. What about 12 over 12? Can I divide by 3? No. So what does that tell you? You need to always make sure you have a common factor in the numerator and the denominator. Otherwise, if it's 3 over 2, could I divide by that? No. So let's use this knowledge to show how we can multiply this in 2 different ways. Based upon the example, are we going to look for common factors for the first way? Did they do that in the first way? No. So let's not do that. We have 4 thirds times 12. What's going to be my numerator? 4 times 12 over 3. What is 4 times 12? 48 over 3. Is that in simplest form? No. How many holes do I have hidden in there? 16. Very good. How many thirds do I have left over? None. So the answer is 16. Now I'm going to show you the second way. We're going to do the same thing. We know that the numerator is 4 times 12 over 3. Do we see any common factors? What common factors do you see, Rahi?
You can divide 12 and 3 by 3.
12 is divisible by 3, and 3 is also divisible by 3. So that means we can think in our head, we're going to divide this by what version of 1?
3 over 3.
We're going to think about dividing by 3 over 3, which is a version of 1. When I do that, what's 12 divided by the 3? 4. What's 3 divided by 3? A lot of times people say, I'm just going to cross out this 3 and leave it there, like that. Then there's nothing there. Can you leave nothing there? When you divide it by 3, what do you actually get? So you have to write what? 1. So now our new problem is 4 times 4 in the numerator, which is 16 over, which is? So you can see we can basically simplify the fraction before we multiply. It's a lot easier when we do that because we're working with smaller numbers.